All right, let's take a look at another example of a chemical reaction. And this time I've got a tip for you, right? And that's start with atoms that are found only in one compound on each side. So we'll see what we mean here. So for this reaction, we're going to say butane, and we haven't learned what butane is. So I'm going to give you the structure. C4H10 is combined with oxygen to form carbon dioxide and water, right? So our first step is going to be taking this chemical or this sentence and forming a chemical equation. So we're told butane C4H10 is combined with oxygen, so plus O, and then remember oxygen is a diatomic gas, so it's going to be O2 to form. So we're forming something, so we're going to give that arrow to the product side. Carbon dioxide is going to be 1 carbon, 2 oxygens, CO2. And then, of course, water is H2O. And then we're going to see how many of each thing we have from the reactant side and the product side. So we have carbon, we have hydrogen, and we have oxygen. On the left side, we have a C4, so we've got 4 carbons. On the right side, we only have 1 CO2, so only 1 carbon. On the left side, we have a C4H10, so 10 hydrogens. On the right side, we've only got 1 H2O, so only 2 hydrogens. Oxygens on the left side, we've got an O2. On the right side, we've got 2 from here and then 1 from here for a total of 3. And so now what we can see is that none of the 3 elements are balanced. So the question you might think about is where to start. So again, my tip is to start with atoms that are only found in one compound on each side. So for example, here we have oxygen is found in 2 compounds. On one side, right? So that's going to give us the hint, don't start with that one. Start with carbon or hydrogen. Right? Don't start with that one, because if you start with that one, it's going to be more complicated than it needs to be, because you're not going to know which oxygen to grab more from. So anyways, we're going to start with another one. It doesn't matter which one you pick. I'm going to pick carbon just because it's the first one. We need more on our product side, and we need to have 4 on our product side. Right now, we only have 1, so we need to put a 4 coefficient there to have 4 carbons to balance that out. When we do that, however, we add 4 more oxygens. So if you think about how many oxygens we have now, it's 9. My bad, we add actually 6 more oxygens, right? We have 4 times 2, so we get 8 oxygens from here, and then a 9th one from over here, 9 total oxygens. So be very careful with the counting. All right, so now more things are balanced. Now our hydrogens aren't balanced, so let's go ahead and try to balance that. So to balance that, I need 10 hydrogens on this side. In order to make that 10, I need to put a 5 right there. So when I put a 5 right there, this goes to 10. So that's balanced. But now we need to think about how many oxygens we have. We have 8 from here, 5 from here, for a total of 13 oxygens. All right. Now I can take a look on my left side and think about how many oxygens do I need. Now here's another hint for you, is we can use fractions as intermediate steps, right? So I need 13 oxygens, but if you think about it, 2 and 2 going to 13, you can't do that with an even number, right? The multiplication there is 6.5. So what I'm going to do, I'm going to go ahead and put a 6.5 right there, 6.5. And I think about how many oxygens I have. 6 times 2 is 12, plus that 1/2 is 13. So now I've got everything balanced. Balance, balance, balance. However, I can't have half of a molecule of oxygen. That doesn't make any sense. So I need to multiply the whole equation to make it a whole number. So what I'm going to do here is I'm going to multiply this whole equation times 2. So now I'm going to have 2 C4H10. Now I'm going to have 13 O2s. Note that now we have a whole number there. 8 CO2 and then 10 H2O. And that'll be my final equation. Of course, we need to double check. We always want to double check. So let's see, on this left side, I've got 8 carbons, 2 times 4. I've got 20 hydrogens, 2 times 10. And then I've got 26 oxygens. Wow, my multiplication is not good. 13 times 2 is 26. On the right side, I've got 8 carbons. So that checks out there, right? 2 times 1 is 8. In terms of the hydrogens, I've got 10 times 2 right there, which is 20. So that checks out right there. And then in terms of the oxygens, I have 16 coming from the CO2, and then another 10 coming from the water for a total of 26. And so then that checks out as well. Again, with balancing chemical equations, it's really just about practice. So if you need more practice, check out the work along and the extra resources and the virtual lab if we're going to do that.